Hi everyone, welcome to our webinar. This webinar is a presentation of Clean Energy Group's Resilient Power Project and the Northeast Electrochemical Energy Storage Cluster, also known as NESC. And our topic for this webinar is Hydrogen and Fuel Cells for Resiliency, Fuel Cells for Telecom. And we have some excellent guest speakers with us today. Before I pass it over to them and to our host for this webinar, I'd like to go over just a few quick housekeeping notes. All of our participants for this webinar are in listen-only mode. You have a couple of options to join the audio portion of this webinar. You can either use your computer's mic and speakers, or you can call in using your telephone. We ask that you please submit your questions as you think of them by typing them into the question box on your webinar console and hitting send. And you can do this at any time during the webinar. We will save time at the end of our presentations for Q&A with our guest speakers. So please do type your questions in as you think of them. We'll get to as many as we can at the end. And finally, this webinar is being recorded. Slides and recording of this webinar will be sent to you by email within 24 hours, and we'll also post them on our website at resilient-power.org. And with that, I'd like to pass it over to our host for this webinar, Todd Alinsky-Paul. Todd is a project director here at Clean Energy Group.
Thank you, and welcome to the webinar, everybody. Are we already advanced one slide, Samantha? This looks like our second slide. In any case, welcome everybody to the webinar, and I will be doing a brief introduction of the topic and the Resilient Power Project, and then I will introduce the speakers. We'll have about 25 minutes or so of presentations and hope to have plenty of time for questions. So as Samantha said, do send those in now. Don't wait till the end. It helps us to kind of have time to sort through them and get to as many as we can and combine the ones that are redundant. So this is a webinar presented under the auspices of our Resilient Power Project here at Clean Energy Group. We are funded by a number of different foundations. As you can see, the overarching direction of the project is to promote clean, resilient power solutions for critical facilities. And as such, hydrogen and fuel cells certainly falls into that category. Next slide, please. For this, yes, I should say that we have a number of case studies, and you can kind of see them on the screen there. They're a little hard to read, but you can access those from our website. And these are case studies of fuel cells in providing resilient power in various applications for various types of facilities. Next slide, please. And I suppose this slide is here because we have revamped our website and we like to show it off. So please come visit the website, download the case studies, review the webinar, which will be recorded and posted soon after it's complete. Next slide, please. So as I said, we have foundation funding, but we also have some other types of funding for the Resilient Power Project, and this webinar is, in particular, is being conducted under a contract we have with Northeastern Electrochemical Energy Storage Cluster, or NESC, which is a network of industry, academic, government, and non-governmental leaders working together to help businesses provide energy storage solutions. Next slide, please. And I'm going to briefly introduce today's speakers. We have Corrine Vita and Thomas Browning, and then we will also have Rick Barant, who is not going to present but is going to be here to help out with fielding questions and discussion. Corrine is the sales director for major accounts at UltraG. She's an experienced major account customer development director whose key focus is on data center, telecommunications, and high-tech customers. She's a specialist in energy efficiency, fuel cells, and data center infrastructure management. Prior to joining UltraG, she managed people and projects at Siemens and IBM. She is adept at feasibility analysis, product development, product launch, developing return on investment, risk management, leading meetings, and managing obstacles. We're also going to hear from Tom Browning, the Senior Manager in the engineering field in South Florida for Metro PCS T-Mobile. Tom has performed in his current role for over 8 years and has been in telecommunications for over 20 years. He has experience in wireless, RF, cellular, and long-distance communication systems, and he is a certified electronics technician, possessing both a BSIT from the University of Phoenix and an MBA from Baker University. He has held numerous leadership and technical positions within Macau Cellular, AT&T Wireless, Sprint, Metro PCS, and T-Mobile. And as I said, we're also joined by Rick Barant, the Vice President of Sales at UltraG, for questions. So before I pass this over to Corinne for the first in our short series of presentations, I want to just say again, we have at this point 87 people who have logged on to join us, and that's a pretty good number. We're pleased that it's a popular topic. If you have a question, it's going to be beneficial if you could type it into the question box now rather than later. Given the number of people, we'll do our best to answer as many as we can. Okay, Corinne, go ahead with your presentation, please.
Okay, thank you, and welcome to the webinar. My name is Corinne Vita, and I'm speaking to you today from San Jose, California. So the first thing I wanted to touch on was climate change and what we're all experiencing with climate change, and that's more severe weather. So certainly in the east, in New York, there was a very bad Hurricane Sandy, knocking out power to millions of customers, and UltraG systems, UltraG fuel cells, were involved in backing up some of those critical networks and enabling communication during that very important time. We've all seen snowstorms, tornadoes, thunderstorms, and certainly where I live, earthquakes. We had a very large, powerful earthquake in the Napa Valley a few years back, and again, UltraG fuel cells were the technology that kept critical networks communicating during that time. So what are the challenges? Why are we here today? Why are we talking about telecom and cable networks? The challenges are with these critical networks to avoid outages and especially disruption of service to customers. And our second speaker, Tom Browning, he's a senior manager, and his responsibility is to keep a very large T-Mobile network operating. So he's going to be very interesting to hear from in terms of his decisions and his technologies that he's using to do that. What we all saw after Katrina was some new regulations in the industry. So the FCC is now putting an 8-hour backup regulation on critical networks, cell sites, broadband, internet, and voice over IP phones. So for example, many of us are doing the triple play, right? We've got cable TV, we've got internet connection, and then we also have our home phone or voice over IP carried across the data network. So it's very important that these networks are hardened and continue to provide customer service. So these are longer run times, but these networks are distributed throughout our neighborhoods, throughout our many different parts of cities, metro areas, and there are frankly space and weight requirements. And so how are you going to provide a solution for longer runtime in these restricted areas? And Tom, again, knows very well the challenge of trying to meet those two objectives. And then you want this to be affordable, frankly. The technology and the solutions have to make sense financially. So we're going to talk about some very important federal investment tax credits and state incentives that enable clean energy and especially fuel cell technology. You want to be sustainable. I think we all want to be good citizens. We want to deploy solutions that have a low environmental impact and that are clean and sustainable. And what I hear a lot from customers with critical networks is every year they get handed a number to reduce operational costs. So, how are they going to do this? They're looking for technologies and ways to meet those objectives. So let's look at the conventional solutions. And there are some challenges, and I think, again, Tom Browning has lived many of these. So there's issues with batteries. They're unpredictable. They're prone to performance degradation, especially with temperature sensitivity. They get cold, they get hot. That's just going to increase the degradation. My husband drives a Ford Fusion, and at the very beginning he got 21 miles on the charge. And now, less than a year later, he's getting 15 miles. So, there is a very big degradation when it comes to battery technology. And especially when it's cold out, he notices that the batteries barely get him, 4 or 5 miles down the road. So again, very prone to temperature. And as you need more and more power output, let's say to meet the FCC requirements or just to harden your networks, batteries are just extremely heavy and large and mass dependent. And then the disposal costs. We all know you can't throw batteries in your trash because guess what? They're full of toxic chemicals like lead and lithium ion. It's very toxic. And this can cause extreme pollution. If it gets into groundwater and soil, this can be very bad. So, and the replacement costs make batteries expensive. Again, you've got to replace them, and you just never quite know how much power you actually have. A lot of guesswork. So another conventional technology is a generator. And generators, they got a lot of moving parts. They need to be oiled. They toxic emissions. They either run on natural gas or diesel, and these are all producing, carbon monoxide. They're extremely noisy. They fail more than perhaps they work. In some cases, they're not reliable. They don't always start, and even when they start, they don't run for very long, again, because of the moving parts and the mechanical issues. Difficulties on rooftop deployments and emissions permits. So those are some of the challenges. So what we're talking about today is important because fuel cells are a terrific solution to these challenges. A fuel cell is a simple device. It combines two of the most common elements on Earth, hydrogen and oxygen, to produce electricity. So it's based on very simple science. It's a reliable, predictable, scientific reaction, and it produces electricity. There's no moving parts. It starts quickly within 10 to 30 seconds. It's used in data centers, telecom, cable networks, and cars. Toyota, General Motors, Honda, they're all you're going to start to see more and more fuel cell cars on the road. They're used in forklifts and buses. That's a very big market because they don't pollute. They have very low maintenance. They're reliable. They're lighter, more compact than these conventional technologies. You can put them on rooftops, and again, Tom Browning has done that in his territory. And they're very environmentally friendly. We'll talk about hydrogen on the next slide, but it's a clean, universal fuel. It can be used to power cars and trucks and heat homes. It can replace fossil fuels, and of course, it can provide on-site, on-demand power when the grid is not available. There's no temperature sensitivity. Fuel cells can actually start at sub-zero temperatures, again, because this is basic chemistry, basic science. They have very long run times. As long as there's fuel, they run, very small footprint, and the incentives and grants are powerful. So for example, there's a federal investment tax credit. And let's say you owe $100,000 on your taxes. The credit is 30%. So 30% of the purchase price of a system. So let's say that you purchase a system and 30% of that is $20,000. Your tax is now dollar for dollar reduced by this tax credit. So instead of owing $100,000, you owe $80,000. So that's very powerful from an incentive standpoint. So let's talk about hydrogen. Hydrogen is a simple, clean, most abundant element on Earth. It's made up of, if you go back to your chemistry, it's one proton and one electron in an atom, and it's two atoms. So you sometimes see hydrogen written as like an H2, so that's for the two atoms. It's found everywhere. It's in water. It's all around us, and it doesn't pollute. It doesn't produce any emissions, and it's extremely light. It carries a lot of energy, and it's very safe. It's been around for many years. It's not explosive like gas or natural gasoline or natural gas. It's 14 times lighter than air, so it just, poof, goes up into the atmosphere and then combines with many of the natural elements in our world, and it's a very sustainable, clean source of energy. It's used today, I know in the consumer market, we don't think about it very much, but there's over 9 million tons of hydrogen produced each year in the United States, and it's used in pharmaceuticals, food, semiconductor, fertilizer, and it can be transported by pipeline, truck, or rail. One other point I want to make about hydrogen, it doesn't age or degrade. It can last hundreds of years. So it's a very good source of energy. And hydrogen is widely available. This is just one of the providers. Again, you don't see it so much on the consumer front, but it's all around us, and it's being provided every day to lots and lots of different users. In California also, I'd just like to mention we have 46 hydrogen gas stations, and that's doubling every year. So there's a very big move on the West Coast to put fueling stations throughout California, and Toyota Mirai has a car that is shipping. It has an 80 kW kilowatt electric engine, and it runs 300 miles on 5 kilograms of hydrogen. So it's very cost effective and very interesting technology that we're going to see more and more of on our roads. So let's talk about critical networks and how fuel cells can help provide solutions. So these pictures show you some various installations of fuel cells. Some of them are on rooftops. The one on the right is on the rooftop. The one on the left is on a pad. They provide both AC and DC power. And I think on the bottom right we see another rooftop, and on the bottom left we see a few more pads. This is the rooftop. This is at Caltech, 55 kW fuel cell running on the roof. The hydrogen storage is also on the roof. This is using hydrogen in a compressed gas cylinder. And then the cylinders are refueled by a truck. A truck comes up once a month or whenever the fueling is required, and refills the cylinders. So they're called fill-in-place cylinders. We also are working with data centers. So we're powering data centers both. We're powering mechanical loads. We're seeing fuel cells powering IT loads, both as a sort of a peak shaving application, especially here in California. We pay a lot of money for electricity, and so to be able to use an alternate technology, a clean technology, to provide power on-site, on demand, it's very attractive to data centers. We're also seeing data centers using fuel cells to power the racks directly and start to eliminate that very expensive high voltage transmission equipment that has to be deployed and providing direct DC power to the racks. So I'm moving quickly because I really want to get to Tom Browning. There are TCOs. If you need a total cost of ownership, there are lots of different numbers out there. This is just one example, but the fuel cell with those investment, those tax credits, as well as the state utility incentives. We have a bunch of incentives in California. The fuel cell cost, we call it the first cost, actually can be lower than alternatives, and then of course over time, there's virtually no maintenance, less than batteries is one comment I've heard, and the fuel cells just, again, they work, they're reliable, they're remotely monitored, so you get diagnostics, you know exactly how much fuel you have, you know exactly how much runtime you have, there's no guesswork, and they really solve a lot of the problems that exist with conventional solutions. So just a touch on UltraG. The company was founded out of Aerojet. So the company founders have a manufacturing background. They used to build solid rocket boosters and work, with space and rockets. So they have they're experts in manufacturing, reliability, and being able to manufacture things cost effectively. So UltraG has a robotic factory, assemble and test every fuel cell so that the quality is consistent and meets all of the high standards. And this also drives the cost down. So it's a reliable, very cost-effective system. It's made out of stainless steel, like the automobile fuel cells, so it's extremely rugged. The earthquake in Napa, it survives earthquakes. There's no issues being shaken. There's no moving parts. So it's an extremely reliable solution, and it's being used in critical networks all over the world. And the final slide, I just want to say thank you again for attending, and UltraG is proud to have the largest deployed fleet in telecom, more than 8.3 million watts deployed, and the field operating time is exceeding 32 million hours. So thanks again, and I'll look forward to your questions.
Great, and thank you, Corinne. I think we're ready to go right on into Tom's presentation. We're ready to go here. We do have quite a few questions already lined up, so if you got one, send it in now. All right, Tom, I'm going to hand it over to you.
All right, thank you, Todd. Thank you, Corinne. Just to talk a little bit about what I'm going to talk about today. For those of you that don't follow Telecom, a couple of years ago, Metro PCS was acquired by T-Mobile. And the majority of what I'm going to talk about was a project that was handled at the time by Metro PCS. So just to set a little bit of background, that's the background, and I'll go ahead and get started. The first, pardon me, one slide too many. The FCC mandate, where this all came from and why Metro PCS got interested in doing this particular project was that in 2008, at the FCC had gotten together to review the aftermath of the Katrina storm. And one of the things they had determined was that part of the size and scope of the impact tied back to a lack of available power backup on the telecommunications side. And at that time, they put together a mandate, and basically what they said was that every telecom carrier out there needed to have 8 hours of power backup. There was some exception allowed, but they didn't. They were kind of nebulous around what that exception would look like and how you could go about getting one. What our interpretation of it was at the time was that if we could reasonably put 8 hours of backup into a cell site, then that's what we'd set out to do. And then if it turned into something incredibly exotic or unreasonably expensive at that time, we would look at it as falling under the exception. The problem with Metro PCS, in particular here in South Florida, was that we have an unlimited data offering and a voice offering as well. And South Florida is, or was at the time, one of the largest markets that Metro PCS had. And what that translates to in terms of power backup is that the more call volume and the more data volume that you're handling, the more power your sites are going to be using. And so what we were looking at here in South Florida was kind of an unusual example of what we would need for power backup. To give you an idea of the differences between what we were looking at here in South Florida and what we were looking at maybe in other markets, for an Alcatel-Lucent cell site, and another market would typically draw about 2.5 kilowatts of power nominal. And here in South Florida, we had sites that were drawing at the time 15 kilowatts. So if you start doing the numbers for what you're going to need for backup, especially for 8 hours, you start coming up with some pretty big numbers. And then the other problem that we had here in South Florida at Metro PCS was that the more call volume that you have and the more data volume you have, the more equipment you need to handle that volume, which equates to pad space or space on our leased area for our cell site. So what we had was kind of the worst case scenario where we were drawing 15 kilowatts of power, and most of our sites, especially being the low-cost service provider, we did not have a lot of space to work with. In many instances, we tried to get to the point where we had two 26 by 26 inch spaces, spaces, and in those two spaces where we're going to have to put some kind of a solution that could provide 15 kilowatts of backup for 8 hours. So kind of to give you an idea on some of the numbers here, if the weight of the typical battery, which is a 170 ampere hour battery, is 120 pounds, each cabinet would have needed 20 batteries and would weigh about 2,800 pounds. So for a site drawing 15 kilowatts, which is the extreme example we're looking at here, we get 2.72 hours of backup for each fully loaded battery cabinet. So for a 15 kilowatt site, it would require 3 fully loaded battery cabinets that would weigh a total of about 8,400 pounds, plus the weight of the cell site itself. So in some instances on the ground, we probably could have pulled that off, assuming that we had the space. But here in South Florida, we have an unusually high number of rooftop sites as well. And things become a problem when you start looking at a rooftop site here in South Florida. If you put an 8,400 pounds worth of battery backup in a cell site on the roof of a condo or something, there's a good chance it might become like an express elevator to the bottom floor. So that was one of the things we had to consider. And then also here in South Florida, we have the additional challenge of having some of the highest wind requirement ratings in the country, with Miami-Dade being in excess of 170 mile per hour wind gust. So as you can imagine, putting batteries on the rooftop really wasn't going to be a good solution. So what we did is we started looking at some different solutions that we might be able to put on a rooftop that would provide what we needed, and that would, and so we started looking at hydrogen fuel cells as one of these possible solutions. And basically what we decided was a hydrogen fuel cell would kind of be, okay, if we can put one of those there, we will. If we can't put one of those there, then that's where it would float into that exception range. Some of the challenging dimensions, so again, the requirements were 26-inch by 26-inch space, 2 of those. And basically the requirement for the bid was that it had to be able to provide 15 kilowatts of power. So we identified in excess of 100 potential site candidates for a hydrogen fuel cell solution. And what we ended up doing was awarding that project to UltraG systems, mainly because of the space constraints that we had. They were they were the only provider out there that was able to provide the amount of power backup that we needed in the space that we needed. So we made a decision to go ahead and move forward with them. We actually ended up moving forward with about in excess of 300 hydrogen fuel cell systems. Now, keeping in mind that one site might use between 1 and 3 different hydrogen fuel cell systems, so exactly what the configuration would look like from site to site could vary quite a bit. Some of the project challenges. The project itself was a huge challenge. It was a huge project of colossal size and scope. We were heading down what I'd call a road less traveled. At the time of the project, it was the largest single deployment of hydrogen fuel cells in history. In addition, there were various jurisdictions that had very little knowledge of hydrogen fuel cells, and we had to leverage UltraG's knowledge to kind of help educate them. When you approach them with hydrogen, they tend to think of things like the Hindenburg and some, everyone is not necessarily really receptive to the idea of hydrogen, especially when you're talking about putting it on rooftops and so on. And due to the number of moving parts in the project, any delays were going to have a critical impact on the outcome. So, oftentimes we found that we were met with a lot of reluctance on the part of the jurisdictions, but once they understood the product and the technology, most of them were really okay with the installation of the fuel cells. What we discovered is that once we got an initial permit approved, the rest moved through pretty quickly. And we actually even had a few jurisdictions inquire about possibly using the technology themselves. In most cases, we were able to move forward. However, there were some cases where the jurisdictions just simply would not allow the hydrogen fuel cells. But again, keeping in mind that at the time, nobody was really doing this. And a lot of these jurisdictions had never been approached about putting hydrogen fuel cells in before. So even in the late stages, of the project, it was actually some of the very, very last sites we're putting in. We had put a hydrogen fuel cell on a local rooftop on top of a hotel here in South Florida, and we failed the final inspection. The inspector actually wanted us to put a lightning rod on top of the hydrogen fuel cell canister. So just to give you an idea, the technology was definitely something that the jurisdictions were still learning about, and I think are still learning about. I don't think it's one of those things they're still 100% familiar with. One of the things that we had to figure out midway through the project was how are we going to actually refuel these hydrogen fuel cells. Most of the markets had, onesie, twosie hydrogen fuel cells where they'd put in a few here or a few there just to see how they performed. And refueling them was really kind of a secondary consideration. So one of the first decisions that we had to make, and that anybody out there who is looking at a similar project will have to make, is whether you're going to rent the bottles or you're going to purchase the bottles. It has a big impact on the project itself in that if you decide that you're going to rent bottles, then most of the hydrogen manufacturers will lease you the bottles and refuel them for you. But if you want to do something which is called a fill in place, basically where somebody pulls up a truck and connects to the front of the hydrogen fuel cell, similar to how you'd fill up a tire on a car. They connect to a CGA connector, and they would fuel the hydrogen fuel cell back up. In order to do that kind of a refueling, you would actually need to purchase your bottles before the site, before the hydrogen fuel cell comes on air. And then it now brings up the question of, okay, what kind of tanks do you want? There are several different kinds of configurations at the time. There was what they called a composite tank, and then there's also what they called steel tanks. And there's a question of, okay, what kind of tanks do I want to use? What am I most comfortable with, and what will I get the most payback from? And then another thing that also comes into play, if that wasn't confusing enough, is then you have to figure out, okay, what kind of pressure do I want to run in the tanks? And if you think about it, in a hydrogen fuel cell environment, you can run with a higher pressure or lower pressure within the tank. Essentially, if you run with higher pressure, you're actually getting more hydrogen into the tank, and so you're going to extend your run times. If you go with lower pressure tanks, you probably have less expensive tanks. You probably have more refueling options, but then you won't have the same amount of run time that you would have with the high pressure tanks. So just to give you an idea of some of the decisions that we had to make as this project went along, and quite frankly, this was some time ago, so there's probably more considerations now than there were even then. And then the other problem that we had and continue to have here in South Florida is that a lot of our hydrogen fuel cells, of course, as I stated earlier in the presentation, ended up on rooftops. Well, the problem, there are some solutions to refueling on rooftops that are probably a lot better than some of the solutions that we tried, which involve pretty much packing steel cylinders up to the roof and so on. We talked about using some type of a hose reel system, which we talked about but never really got around to trying out. I think some of the things we're probably more likely to look at now would be to include running maybe a fuel line from somewhere down below on the ground level up to the rooftop and refueling that way. Those are all options, but again, the low pressure, high pressure, a lot of those other things all come into play on these decisions. So make sure that if you do head down this route, you're well educated and don't have any surprises coming out the end. What we ended up doing here in South Florida, just I guess for the benefit of everyone on the call, was we ended up creating a bottle swap process. And in other Metro PCS markets where later on they also got hydrogen fuel cells, this also ended up being their approach. And basically what they did, or what we did, was we had a surplus of steel tanks that we had purchased. We kept them fueled up and ready, and then we would essentially hire somebody to come in and swap the tanks out, the full ones with the empties. Basically, they would then take the empties, get them refueled, and they would replace the full ones that they just took out of our pool of fueled up tanks. So I mean, that's one approach to it. We also did try some bump in place for the rooftops. I can tell you the bottle swaps probably ended up being the best route for us. As far as the bump in place, I think, or fill in place, if you want to call it that, where you basically pull in the vehicle and refuel that way, it's getting better. The refueling vehicles are getting smaller and smaller. They've kind of gone from tankers down to something that you can, fit in a fairly compact area. So more and more options there. Right now, our hydrogen fuel cells are kind of in transition. So as it currently stands, we're not getting any of them refueled. So and some of the operational considerations from what we saw, and again, this was some time ago. I think we actually moved through this project in 2008 and 2009. What we had to make some decisions around fueling. The solution we chose, which was UltraG, has some very sophisticated alarming and a lot of logic circuitry and everything. can tell you a lot of information about it. But in a telecom environment, at least we made the decision at the time to go with basically dry contacts and what I call a summary alarm. So what we did is we would summarize all the alarms into a single alarm just to tell us that we had some kind of a fault or trouble. Keeping in mind these were actually backup systems and not, for the most part, we weren't really running off any of these as primary power. The other thing we decided to do was, as far as refueling and fuel capacity, we were able to get the cell sites or the hydrogen fuel cells to trigger at 40% and give us an idea of when they needed to be refueling. And the significance of that in South Florida is that if we find out there's a hurricane headed towards South Florida, which we usually know several days in advance, we can go out and get every hydrogen fuel cell that's below 40% refueled before the storm were to come in, hopefully. What does it cost to refuel one? On average, we spent $571 a year to fuel and maintain each site. Keep in mind that the $571 really was more or less just refueling. One or more times a year. We don't really have the most reliable power here in South Florida, so we ended up actually doing a lot more refueling than I had initially anticipated. If you're actually out with this hydrogen fuel cell, when one of them flips on, you probably won't even know that it's running. It's very, very quiet. You'll hear a little fan power up, and really that's about it, which is really nice because you are not likely to have landlords or anyone like that complaining about the noise they make. Compared to our generators, the fuel cells are really less expensive to own and significantly more reliable, or at least were at that time. The other thing is they don't need to power up and load test. They do a self-test, and they'll let you know if there's anything wrong with them or they need or they have some kind of an issue. They don't require a transfer switch, which for those of you that have worked with generators know that transfer switches tend to have a high failure rate, and they're also very expensive. One of the nice things about the hydrogen fuel cell too is that you can determine how much power backup you want just by adding more bottles. So if you put in 6 bottles and find, what, I really wish that I had twice the backup, you can move to 6 more bottles, or you could move to a high pressure system, and you could considerably increase your runtime. So the thing is, we found hydrogen fuel cells to be, with Metro PCS to be very robust, simple to work with. They seem to be highly reliable. One of the things that we also had to do here was to get local contractors trained up to work with them. Especially if you're somebody who does a lot of site reconfigurations and so on, you'll need somebody who's trained to work on the hydrogen fuel cells. As it currently stands, we have our hydrogen fuel cells went through a couple transitions. One, we converted them from plus 24 volts over to neg 48 volts. For those of you that don't know, these are DC powered systems. So if you change the voltage on your DC powered system, you have limited options as far as exactly how you're going to handle that. For that reason, actually right now, we've got a few of them that are kind of in a holding pattern to possibly get redeployed in the near future. See, one other thing, one of the considerations, and I think this is actually generally true in telecom, is that the power requirements across the network are typically declining. We're adding more technologies, but the technologies tend to get more and more efficient. And the technologies on the wireless side tend to cover smaller and smaller areas. So one possibility with the hydrogen fuel cells is they work in 5 kilowatt chunks, so it's possible to redeploy them into different configurations. And that's really all I have. and I can go ahead and hand it back to Todd.
Okay, great. Thanks very much, Tom and Corrine. We have a bunch of questions and about 15 minutes, so I'll just start going through these questions, and unless I direct it to somebody in particular, feel free to jump in. So the first thing is regarding the FCC regulation that you referred to, and we have a few questions on this. Who is responsible for providing, you said, eight hours of resilience? I mean, is that in a particular geographical area? Is that just for new cell sites, or does that apply also to existing ones? What's the actual requirement?
You know what? And it was one of those things I mentioned. I meant to touch on, but did not. The FCC mandate never really went away, but it got put on hold for legal reasons. I think that, and again, I'm not a legal expert, but I think one of those reasons really had to do that it wasn't really clearly defined to that individual's question. So, I mean, the best answer I have right now is it was kind of put on indefinitely on hold and never really picked back up. It made sense to us to go ahead and move forward with the hydrogen fuel cells anyway. We were able to get some really excellent credits from the state of Florida that made them really very, very reasonable from a cost standpoint, and we needed the power backup either way.
Okay,
Todd, it's Corrine.
Yeah, go ahead.
Yeah, I would just comment that it does apply across the board, but as Tom mentioned, it's constantly being discussed, and I know that there are many sites that apply for, sort of a pass. In other words, they're restricted by their size, their location. So I would say it's a target that the FCC, it is written as a regulation, but there are all kinds of, options that the carriers are using to, either get a site, a pass from the regulation, or as Tom said, sometimes it just makes good business sense, no matter what the FCC said, to not have your customers disrupted during power outages. So those are my thoughts.
Okay, sure. Just to follow up on that, then, it seems to me, not knowing much about cell towers, that it doesn't help much to have one or two towers be provided with resilient power. You really need to provide a bunch of them, correct? I mean, otherwise, who's your tower going to communicate with? Is that how do you figure that out? In other words, if your town is concerned about frequent grid outages for various reasons, and you want to have a resilient communications network, and maybe you've got a few towers that serve your town, does it help to just address those, or do you need to address the entire network?
If that question's for me, I mean, you're absolutely right. Probably don't need to back up, and probably don't need to have 8 hours of backup on every single tower in the network. But at the time, the FCC mandate was that you would have it. Again, it kind of got put on hold. So, I mean, reasoning stands that you would only back up those most critical and those things that you really had to back up. But we were going with really what was the FCC mandate at the time. Yeah, and again, it just kind of stalled out and never really went anywhere. That was 6, 7, 8 years ago now, and it's still, I think, probably shelved for now.
Okay, thanks. What I was trying to ask was whether providing for resiliency at one or two or 4 or 5 towers is going to have the desired effect, or whether you really need to support a bunch of them so that you have somebody else to communicate with when the grid is down.
Yeah,
I think. Yeah, go ahead, Tom. You prioritize your towers, right? I mean, you have areas of metro, especially metro areas, that you might consider higher priority, more density of customers.
Yeah, at Metro, a lot of it had to do with, yes, the sites that we had in the more dense areas that would handle a lot of call volume, and as well as the footprint. But I think if I understand your question correctly, it was really around backhaul and being able to get the signal back to the switch. To me, that was kind of one area that I think the FCC wasn't real clear on. We can have a cell site out, and it can have 8 hours or 12 hours or 5 days of backup. But if the backhaul from the cell site back to the switch has only got a half an hour of battery backup or power backup, then the site's still going down after a half hour. So, is that
thanks.
Your question?
Yeah, that was what I was trying to get at. So you really need to look at the lines of communication within the network to figure out which ones need to be supported. Is I think what we're getting at here. Okay, so another question regarding the various types of interruption. Obviously, the Northeast and the East Coast in general sees a lot of storms, but in other parts of the country that's not necessarily the issue. Somebody wants to know how fuel cells remain resilient in earthquake regions when the fuel source can be interrupted. Somebody want to take a crack at that one?
Yeah, I guess I'll take that since I live in San Jose, earthquake country. So the fuel is actually on site with the fuel cell. So as Tom was mentioning, the fuel is provided typically in steel cylinders or composite cylinders. And those sit right next to the fuel cell at these long haul and metro network sites, and they are in cabinets that are weather conditioned as well as seismic conditioned, so the fuel is available during those events, during earthquakes.
Okay.
It's not interrupted. I guess that's
great. So, but it is finite. So then, at what point? How long does that last before somebody has to be able to get out there and either
right? So as Tom mentioned,
replace it?
Yeah, great question. So as Tom mentioned, there's monitoring, that takes place continuously. So if the fuel level, Tom has chosen a 40%. Alarm condition or notification, but you could choose whatever level your requirements needed, and that could set off a notification, and then fuel could be provided. Fuel is provided in a number of ways. Either a cylinder could be transported out to the site, a truck could come with hydrogen. So you've got a couple of different options. Obviously, if all the roads are out, that would be a challenge for diesel, for propane, for any on-site, on-demand fuel. Gas lines typically are the first thing shut off in earthquakes. So, people think, oh, the gas lines aren't going to go down. Well, actually, they do go down, and they're very susceptible. The first thing that the utilities will do in earthquakes is they're going to shut the gas off. So you do need on-site fuel. Hydrogen can be stored on-site very compactly. As Tom said, you have choices. You could choose 6 bottles, 8 bottles, 10 bottles. You make your choice, and that provides you the fuel, and then you get the notifications when the fuel starts to get reduced. And if you need more fuel, then obviously you've got to get fuel to the site.
Great, thank you. Here's an economics question and a follow-up from the same individual. The question is, what are you currently paying for hydrogen? Obviously, that's going to vary depending on where you are. And then the second question is, what would you estimate for a hydrogen cost that will produce significant expansion of your product sales?
The current price for hydrogen, it does vary. I mean, it's very hard. I'll just throw out a round number, $5 per kilogram. I mean, that's just an estimate. And then what was the second part of the question?
The second part was, where does that price need to be to create a significant expansion of your product sales? I think the overall intent of the question is, where's the pricing now, and what's the point that you'd like to see it get to in order to make this, kind of a system more competitive or more attractive?
So, Corinne, let me try to answer that one.
Yeah, okay.
This is Rick. Yeah, and you're right. Hydrogen does vary in price and depends on how far it gets delivered. So with the new infrastructure coming with the automobile, we're anticipating the costs to deliver fuel to come down. As Corinne said, $5 hydrogen is really attractive. I mean, that's really competitive with the grid. The challenge becomes the delivery of the fuel, and that's where the cost comes from. So as the network improves, and as the fuel stations are deployed, and as hydrogen becomes more acceptable, the cost for transportation and the peripheral cost really comes down, because the core cost of hydrogen makes a lot of energy. There's a lot of a kilogram of hydrogen. It's the cost to get it there and how we're going to store it. And those costs, like Tom had said earlier, have dropped quite a bit from when we installed his systems. And the methods on delivery with fill in place and reformation, we really can compete with the grid. And a lot of the larger sites that we're working on now for data centers, for instance, would require quite a bit of hydrogen. And we're seeing prices now that truly challenge the utility grid, which is a very, very effective energy delivery system that we have today. And we've got some great models and some good forward-looking forecasts that are very exciting. Todd?
Okay, great, thank you. So here's another question. This is about storage. Are there long-term storage issues with hydrogen, and how close are we to a storage facility that doesn't leak?
I guess that's a technical one. I'll take that question too. To answer the second part first, there really isn't leakage. It's a very small molecule, of course, and we are very careful with the technologies we use to store and to deliver the hydrogen from the tank to the fuel cell. So we've really got that under control nicely, and there's there really isn't leakage that would be considered leakage. The tank doesn't evaporate. You don't lose it like you could lose or ruin diesel fuel. That could go bad, or it could gel, or it could get moldy. The fuels of today with biofuels, with diesel and gasoline, decay much quicker these days than they did in the past because of the different processes used to make those types of fuels. Where hydrogen, on the other hand, if you keep it in a cylinder and there's no leak, it'll last 100 years. It does not decay, it does not degrade, and it always has the energy component in it the day you filled it as it did 10 or 100 years later.
Okay, thank you. Here's a good question. How many fuel cells are currently in operation in T-Mobile's network? I guess that would be specifically at cell sites, I suppose, not including, forklifts or something like that.
Yeah, that's a question I didn't really come prepared to answer. I don't have an answer for you. I am primarily South Florida, so I only have visibility to South Florida, and so I really I apologize, but I can't answer that question.
Okay. It's all right. So here's another question, and this is probably going to be the last one, so we're about out of time here. What's the experience been with the UltraG systems in sustained freezing conditions such as the Northeast?
I guess I'll take that one since I'm familiar with all the deployed markets. The rating of the fuel cell is a -40 to +50 C rating. So in environments where it freezes, there's a small heater in every cabinet, which is typically maintained throughout the life of the system. So we'll keep it just above freezing, and once the system starts, you'll lose electricity, obviously, So there's a small DC heater in there or an AC heater in the cabinet. But once you lose the grid or you lose power, the fuel cell starts up, and then we maintain the temperature inside the cabinet ourselves. So you could run indefinitely. In fact, up in Connecticut for a number of years, we've had systems running 24/7, and there was no utility grid whatsoever, and it would get bitter cold there, and the system would continue to operate without interruption because we do create our own environment once we run.
Okay, great. Unfortunately, we've reached the end of the hour. We have a bunch of other questions. I apologize to those whose questions were not answered, and hope you'll come back for the next webinar, and we'll try to get to your questions then. I want to thank Corrine Vita, Thomas Browning, and Rick Barant, and thanks to everybody who attended. Samantha, do you have any closing words?
Well, I just put some info on the screen about how you can contact us and find more information about the resources we have and the work we're doing, as well as upcoming webinars. So I hope you'll check us out. We do have 2 webinars next week on fuel cells. I don't know if you wanted to say anything about that, Todd.
I don't think it's on fuel cells, actually.
Oh, sorry, flow batteries. Sorry.
Flow batteries, right. Similar but different. So yeah, there's 2 webinars next week on flow batteries. Check that out at our website and register if you're interested, and we'll see you then. Thanks, everybody.